Okay, so welcome to the next part of the lecture. And in this part of the lecture, what we're going to be doing is completing the square. So the completing the square is a method that we can use for factorizing problems which are typically quite difficult or some that we can't solve like we did last week. So for example, if we take the function of x squared minus 2x, and we say that y equals x squared minus 2x, and we want to find out when that crosses 0, this isn't straightforward. We can't actually see the same way in which we saw last week. We can't figure out what the factors are. But perhaps we could say, well, what happens if we add something to it? So we say x squared maybe minus 2x. I'm going to add a 1 on. We're going to add a 1 to both sides, equals 1. Now we have a factor. And I can say, well, actually, when you have both two negatives on that side, well, something minus something equals 2 and something times by something equals 1, so it's both got to be 1. That has to equal 1. Therefore, a bit of tidying up shows us that x minus 1 squared equals 1. Therefore, x minus 1 equals the square root of 1. Because we have two solutions to the problem, this is plus or minus 1. So x would equal 1 plus or minus the square root of 1. So x equals 1 plus 1, which equals 2, or x equals 1 minus 1, which equals 0. And if we have the technology, we can go and we can see what this would look like on the plot. If this was plotted as an equation, and we see, lo and behold, it crosses at 0 and it crosses by 2. And by adding that factor, all I was actually doing was I was shifting the graph up by 1 so it touched. So the base of the graph was now touching, the base of the plot was touching on the x-axis. So by doing that, I was actually just doing some graphical transformations, which we don't really talk about much in this lecture series, but maybe will in years to come. But what we were doing is we were just shifting this up by adding a factor on the x-axis. So we can actually follow an equation for this and how we get it into this squared form. And that would be x squared plus 2ax plus a squared equals x plus a squared. So this is basically saying if we want to get it into the form where it's pushed up to help us solve the answer, we need to add on this squared term, which comes, this a term, which comes from here. Okay, so let's try it with some numbers. If we have something like x squared plus 6x equals 0, okay, so we want to now try and solve this, so we need to get it into this form. So we know that 2 times a has got to equal 6, so we say 2a equals 6, so a has to equal 3. We can say that x squared plus 6x plus our a squared equals a squared. Quite simple. So x squared plus 6x plus 3 squared equals 3 squared, which equals x squared plus 6x plus 9 equals 9. Okay, so we know what form. So we've shown that this can now be described in this form with the a. So x plus 3, therefore squared, equals 9. And we've got now our solution to our problem. So x equals, the square root equals negative 3 plus or minus square root of 9. So x equals negative 3 plus or minus 3. Therefore, x equals negative 3 plus 3, which equals 0, or x equals negative 3, which equals, equals minus 6. So now we go back to our calculator. We have two solutions to our problem. I'd want the two solutions in the exam. And we see if we plot these two plots, we have crossing at 0 and we have crossing at 6. So we've got the answer right at negative 6. And all we've done by completing the square is we've raised the plot up so it touches the x-axis. It's quite straightforward. Okay, so maybe we have something slightly more difficult when we have a coefficient. So maybe we have something like, I don't know, 2x squared plus x. So I'm going to bring this equation up back here. I'm going to put this to 0. I'm going to say that x squared plus 2ax plus a squared has to equal x plus a. This is so you don't forget it and so I don't forget it. So what can we do here? Well, what we've got to do is take a factor of 2 out to get it into the same form as this here. So we say 2x squared plus x divided by 2 equals 0. Right, okay, so what's our a? So inside of these brackets, remember we're timesing by 2 every time, inside of these brackets is 2a equals, well, we're going to say a half, because that's x over 2. So a has to equal, so 2 times 2 is 4, a quarter. Okay, so our answer would be 2x squared plus x over 2 plus a quarter squared equals a quarter squared multiplied by 2. So 2 multiplied by a quarter squared. So let's tidy this up a bit. We would have 2x squared plus, and we'll call this a half x for tidiness, plus, so we have 1 squared equals 1, 4 squared is 4 times 4 is 16, and that equals the same over here. So that's 2 times by 1 divided by 16. So the answer would be 2x squared plus a half x plus 16 equals 1 over 8. And that also then means we can put this into the same factor as this here, or the same form as that here. So we have 2x plus our a, which is a quarter, squared equals an eighth. And that would be the answer to our solution. So if we were then, 2 times 16, yeah, it would be an eighth, and we could then work out our solution to our problem from this. I won't go on to do that, but you could do that in your own time if you wished. Okay, so maybe we have a negative coefficient on here as 2, so this makes it a little bit tricky as well, but it's actually the same thing. So maybe we have something like negative x squared plus 4x. Okay, and we'll bring our equation back in the corner. We have x squared plus 2ax plus a squared, and that has to equal x plus a squared. Okay, so I'm going to say that equals 0, and what I'm going to do, first of all, is take a negative 1 out of here. I'm going to put some big brackets, and I'm going to say that is x, so negative 1 times by negative x equals x squared, and then we're going to do the same for here, negative 1 times by 4, which is negative 4x, okay, and that equals 0. So we want to find our a here, so 2a equals negative 4, so a equals negative 2. So we get it into the form we want it. So we say that negative 1 brackets x squared minus 4x, and then we say plus, and then we open our brackets, negative 2 squared, and then on the other side we're going to have so negative 2 squared times by minus 1, so negative 1 times by negative 2 squared. I'm going to put a little time sign in, which you don't usually like, and then we begin to tidy all this up a little bit. We're going to see that that equals negative 1x squared minus 4x plus negative 2 squared, which is 4, equals negative 2 squared times by minus 1, which is negative 4. And then if we look at our final answer, we could maybe multiply all this through by 0 if we through negative 1 if we wanted to, or we can keep it as it is. We can say that negative 1, open our brackets, is negative, open our brackets is the same as saying that, multiplied by x plus negative 2, squared equals negative 4, and let's just tidy this up a little bit. We can times 2 and say x negative 2 squared equals 4, and that would be our answer, and that would be a solution which we could just go through and solve. Okay, so now kind of an exam style question that I'd ask you. So a typical exam style question I'd ask maybe is solve x squared minus 4x minus 2 equals 0 using completing the square. So the first thing in this case I would do is get the equation up, x squared plus 2x plus a x, sorry, plus a squared, and that equals x plus a squared. So we're not forgetting. And next we're going to calculate a. Okay. So a has to equal, well, -4 against 2a equals -4. So a equals -2. So this is our answer. We'll keep that there. So x squared minus 4x minus 2 equals 0. So x squared minus 4x. This wasn't in the form that we've been messing around with before. So we're going to say x minus 4x. I'm going to say that equals 2. That's because I'm moving that to that side. Okay. And now we can begin to get it into the same form. We could say that x squared minus 4x, and we now want to put in this -2, so that's plus -2 squared equals 2, which we've got from here. I'm going to say plus -2 squared. Okay, so we have our answer, so we can begin to tidy this up a little bit. We have x squared minus 4x plus 4 equals 2 plus -2 squared, which equals 6. We can again get this into this form here. So we can say that x plus it's our -4, sorry. So it's -2 equals 6. So we then have a solution to our problem. We can say that, well, that's going to be x equals 2 plus or minus the square root of 6. So I don't have a calculator with me, so we could leave it in that form. I'd be happy for that as an exam answer. Or you could say, we can check it with a bit of a guess. We'll do it graphically. So the square root of 3 is 9, square root of 2 is 6, in between 1 is about 4. So we're going to say it's about 2.4 is the square root of 6. So 2 plus or minus 2.4. So the minus being minus 0.4 or 4.4. And if we just check on our graphical calculator for sanity, we'll see it's right, minus 0.4 or 4.4. So that's our answer to our solution. So that would be correct, and that would be a full marking the exam. So finally, let's just go on to a more complicated question. This might be one of these 8-mark questions or that we ask at the later half of the exam, or it might be part of one of the 8-mark questions which will be in the exam. So if we have the equation like 2x squared minus 3x minus 3 equals 0, when we're asked to solve it, we've got to do a few things and a few of the tricks that we've actually done previously. So let's get our equation back up we had before. X squared plus 2ax plus a squared equals x plus a squared. Okay, so first thing we want to do here is take out a 2 out of the brackets like we did earlier. So 2x squared minus 3 over 2x, and we're going to have another minus. We'll move this to the other side as well. So we'll have that over here, as we'll have that as a 3 over 2 as well. So 3 over 2. So we're dividing by 2, so we're going to have that as 3 over 2. Okay, so we've divided both sides so we can get rid of this 2 on the outside. A little bit more tidier, we can say that that negative's gone over there, and so that x squared minus 3 over 2x equals 3 over 2. So all we've done here is we've taken a 2 out of all these numbers. Because we have something on the other side, we can get rid of the brackets. So that's x squared minus 3 over 2 equals 3 over 2. So we've now got something in the form that we want it. So we can say that 2a equals -3 over 2. So a has to equal -3 over 4. So we want to square that as well when we're coming up in a second. So we get it into this form. So we'd say that x squared minus 3 over 2x. And then we're going to say is plus -3 over 4 squared equals 3 over 2 plus -3 over 4 squared. So we'll tidy this up a little bit. We have x squared minus 3 over 2x plus, that would be 3 squared is 9, 4 squared is 16. It's negative because it's a squared term, that negative disappears, equals 3 over 2, 2 plus 9 over 16. And here we have some of our fractions from last week. If you remember those as well, what we can do for like terms. We want to find something which is a common factor. Well, here the easiest one is 16. So we have to multiply this through so we'd have to multiply by 2 times by 8. So we'd get our factor. And if we just multiply, if we do this quite neatly and quickly, we'd say there's an 8 there, 8, 16, 24, 24 plus 9. So we'll do that a little bit there. So we'd say that equals 24, 8, 16, 24 divided by 16 plus 9 over 16 is our common factor. And we can then say, bringing our factor from up here, x minus 3 over 4 squared equals 24 plus 9, which is 33 over 16. And then we can put our solution in surd form again. So we'd say that x equals 3 over 4 plus or minus the square root of 33 over 16. And that would be our answer. Okay, so that's been a few solutions to some problems, but what we're going to do next is we're going to work through a method, and in this method we're going to look at creating a generic function from this method which we can use on any quadratic function.